about earthing. Earthing is very important when it comes to electrical installations, be it single phase or three phase. When you are doing an electrical installation in a domestic setup, an industrial setup, a commercial setup, this is a very important aspect when it comes to safety. Now, today we will be discussing about that. Top boss, if you are geared up for this event, then let me know by simply having you to tap on that like button, my top boss. On my board, I have this electric pole and I have a meter. This is a smart meter that is mounted on the pole. I have a representation of now what was the meter box. We have our meter here, that is a smart meter, and it is placed there for reasons that I will be explaining. And then we have our meter box here, whereby there is an interface between the grid and the customer. From this box, we now go to the consumer unit. And this one here, if you can be able to see, is a representation of a commercial setup where you have several flats or several houses, and you will have a connection at this pole. This is a three-phase connection. So we will be talking about that, my top boss. Let us get excited about our today's session, and I will really be glad to have you press that like button. Also, my top boss, this is one thing that I really do appreciate, is to know where are you streaming from. I have a lot of followers from Gambia, Ghana, Nigeria, South Sudan, Somalia, as well as Kenya. Massive following. Thank you so much. I really do appreciate. A lot of top bosses are in college, and I always appreciate interacting with them. When you are studying and you find time to interact with my content, my top boss, I salute you. Let me know, where are you studying from? Is it Rift Valley Technical College? Is it Nairobi University? Kenyatta University? These are some of the colleges or institutions that are in Kenya. And I have massive respect for my top bosses who follow me from there. Thank you so much for always finding time out of your schedule to listen to me and watch my content as well. Now, to talk about the basics of earthing, let me just bring you closer to my whiteboard here, and thank you so much for finding time to tune in to this live event so that we can be able to talk about this important aspect, which is definitely earthing. Yes, so on my whiteboard, what I have here is this particular point where I have this smart meter. Now I want to introduce something here that we normally see, which is referred to as a PME. What is a PME in full? Top boss, for me to know that we are together and you're following, kindly tell me a PME in full. So let me just draw it. If you have been keen on the electric poles, you might have seen the PME definitely. And normally that is a conductor that is that way. And then there is, it goes all the way to the ground. Now the PME, you will find that there is a loop here, and this loop is rectangular in nature, and you will find that there is a case there, or probably there is a metallic part on the pole which now is written or has an indication PME. It is usually yellow, and then you have the lettering PME on it. So allow me to use this red mark, PME. And then Definitely this one goes all the way to the ground. And then at this particular point, you'll find that this conductor here will go all the way and be connected to the neutral connection that is on the national grid. So if at all we are talking about a single phase connection, this single phase connection, we normally call it single phase because we have the phase which supplies now this type of the connection with the live connection, and we have the neutral which acts as a return path to the transformer. Okay, the transformer is also earthed, or there is an earthing at the transformer. Now, for us to understand this PME, at this particular point, we have said that the connection is done to the neutral wire. Now, I wanted to know from you, my top boss, what is PME in full? Yeah, what is PME in full? And I also have a great top boss here who has said that he is Namyalo Prosi. Good afternoon, John. I'm Sentongo John from Uganda, and I love electricity a lot. Wow, wow. Thank you so much, my namesake. My namesake, I normally see you interacting with my content, and it means a lot. It's not the first time that I'm seeing you, and it means a lot to have you all the way from Uganda. Thank you so much for joining in this live session. PME in full. My namesake, John. What is it? Sentongo from Uganda. What a great name. Great people have great names, and those people will definitely succeed in life. Yes. So our PME is connected at the neutral conductor, which is a return path to the transformer. I have a lot of passion when it comes to this particular connection here, the PME. Now, if at all there is an issue at this particular point, remember several customers can be connected at this pole. All right. So here we will have this PME serving several people that have been connected here. Assuming that we have another setup whereby there will be required a connection for that, for another to tap in another customer or another building or another business, they will be tapped here, the neutral and the live, and then this PME will serve all of them. Now, what happens in case there is an issue of charges here? Then this PME will take all of these excessive charges. Remember, earthing is a creation of a smooth or a safer path for electrical charges, especially the bad electrical charges, which have actually found their way. Let's say, for instance, at this particular point, you have excessive charges, bad charges. So this PME that is here will definitely create a safer path. Any leakages in electrical can be dangerous to people or to animals, and therefore they should find their way to the ground. The PME creates that path which is very safe as well as faster, because electrical charges, especially the one that has actually escaped from an appliance or from an electrical circuit, allow me to use escape, it will find its way through this PME if we are talking at the pole level. Now, once it gets in the ground, it will not just go to that ground or just disappear in the mass like people think. Let's say this is the ground. So we have trees, we have vegetation, and then this one is the part whereby you have the soil, you have probably water, you have the rocks. So if at all these charges find their way in the ground, So let's say through the PME, so you have the charges. The charges don't stick at that particular point in the ground, but they find their way. Where do the charges go to, my top boss? All right, let me know. Where do you think these charges go? Or what happens to them once they are in the ground, right? So let us interact. Let me know, like I requested you, where are you streaming from, as well as let me know if you are finding value out of this session for today. Smash the like button so that I can actually know that you are finding value. So once the charges are in the ground, my top boss, they will find their way back to the source. Remember, our source comes through the live connection or the phase. And then for the circuit to be complete, it has to go back to the source through the neutral conductor. So that is how you get a complete circuit. Okay, so from the transformer, which is our source in this case, the electricity will flow, or the electric current will flow through the phase. It can be, if at all it is a single phase, it can be through this live phase, or if at all is a three phase, it can be the red phase, the yellow phase, or the blue phase. All right, so a single phase can be tapped from a transformer which is a three phase. Assuming that in that area you need a connection for single phase as well as three phase, there can be a line that is supplied to, let's say, domestic houses or domestic connections whereby it only requires a single phase. There are other connections which are commercial whereby you require a three-phase connection. But for this particular case, let us concentrate with a single phase connection where the live connection will be connected and then the neutral will be the return path to the transformer to make a complete circuit. All right, so once the charges escape and find their way to the ground, they do not just disappear to the ground. You know, they will find their way to the source. So they will go back all the way to the transformer, and at the transformer they will now return as safe electricity again through the phase and then back. Now, if for instance in a domestic setup you have a connection for your home appliances, let's say the fridge, the refrigerator, or the dispenser, or that microwave, or the lighting circuit, it will have to go back through the neutral so that you have a complete circuit. This happens in split seconds, or should I say microseconds or milliseconds, so that you have that complete circuit. So that is the basic function of the PME. It will ensure that at the pole level you are covered. Now, in other cases, you find that this meter is actually in the meter box. Now, for that, you normally have the cutout, and then the cutout is linked or looped with the earth connection. Now, let us talk about the earth connection at this particular point. So if we have the meter here at the pole, if you have come across that, and I will be sharing about that in our subsequent live session or the videos, top boss, you'll check them out. So if you have the meter here, you'll have the meter box here, and you'll probably not be having that cutout at this particular level. Remember, a cutout has a fuse. It must be able to be accessed easily so that if at all there is an issue, someone can access there, a qualified electrical technician, so that they can be able to replace the fuse if at all it is damaged. They can be able to check on loose connections and fix it. They can be able to check on arcing, and if at all there is an issue of that, they will be able to fix it. So this setup will not be at the pole. The only thing that is at the pole is the meter, and the reason why it is set up like so is for reasons to do with, let's say there is a default pay, let's say someone was tampering with the meter and the utility company decides that they will want to have their meter there to make it hard for any person that was interfering with their energy meter, so that they will only have access to something that they cannot have a lot of losses whenever it is interfered with. All right, my top boss, where are you streaming from? How is the live coming along for you? And if you are getting value, kindly hit the like button. And if you are not a subscriber to my channel, then you will be missing a lot, especially on the videos that we are about to cover. This being earthing or safety in electrical. Okay, so regarding a meter that is at the pole, that is what happens, and especially if it is a smart meter, meaning that probably they noticed that the consumer was interfering with the meter or denying the utility company access to their property to check on the meter. Remember, the energy meter is still a property of the utility company. For instance, here in Kenya, our utility company is Kenya Power. If they supply you with electricity, they definitely have an energy meter. This is their property. You can have a lot of access here, a lot of authority at this particular point, but the energy meter should never be interfered with, especially by the owner of that property. In many cases, you'll find that they will have that seal. They will lock that energy meter, denying you access to it. For instance, there are these meters which are referred to as the prepaid meters, or what we normally refer to as the token meters. These prepaid meters will have a lock on them, which we normally refer to as, there's this term. What is the term referred to that? Whenever you interfere or you unscrew that uh, uh, prepaid meter, it will ask for a code. This code is referred to as a tamper code. Remember, for you to access this tamper code, you must get to them for them to give it to you. Now, it is not an easy process, because then they will say that there is something that you are trying to do, and probably you are trying to bypass so that you can use electricity, without paying. But technology has made it in a manner that for you to have electricity, you must be able, to pay first. For instance, if we are talking about the prepaid, you have to pay first for you to access electricity. Any issue or any tampering will definitely put you into further problems with the utility company. So that setup for the smart meter that is pole mounted can be either a prepaid or a postpaid. But either way, if you have this smart meter here, or if you have a prepaid meter on the pole, then the PME connection must be connected to the neutral. At this particular point here, what we have been having is a drop cable, and the drop cable looks like this, my top boss. So the drop cable has important features that I would like us to talk about. And what I have here is a 16 mm drop cable. Important features of this drop cable is that it only has two wires inside, or two cables, or two connections, point of connections. All right, don't know whether it is clearly visible to you, my top boss. If you're able to view it clearly, smash that like button. What colors are here? Normally you have this one coming here as a red cable. That is the calibration that we have in our country. If it is a single phase, we have the phase as red color. All right. And then this one, I have already insulated it, but normally what this cable comes in looking as, and especially if you are a student, you'll really learn a lot from this, because myself, I was not privy to this information until I was in the field. So for that drop cable, which drops from the electricity pole that is immediately serving your customer with the power, this is how the cable is. All right. So the cable looks like this. So you have the face as red. The insulation is usually red. That is the color code. And then this one is just plainly like that. So when connecting it, you will connect these at the cutout, the face cutout. Sometimes you can have two cutouts whereby you have the connection for the face, where you'll connect the face, and then the connection for the neutral. All right. So what we have been connecting is that some meters will be connected, and you will have to bond the earth connection to this particular point. Now, for the smart meters and many meters that are coming up nowadays, if you loop the earth and the neutral at this particular point, then the meter will start counting very fast. Remember, that is a bond that is done after the meter, whereby you connect this cutout here, the neutral and the earth connection. And if at all you have already done this connection where you have the PME standing for protective multiple earthing, which has been connected at the neutral on the pole, there is no point of again looping the neutral after the energy meter. That is a topic that we have really been having issues with many electricians online, because my question would be, why again would you need to loop the neutral and the earth? All right. So once this drop cable comes in, if at all you have the meter mounted at this particular point, you don't need to bond the neutral and the earth again at this particular point, because already the meter has been bonded. Already the neutral has been bonded with the earth at the PME. When it comes to this particular point, if at all the meter is now in the meter box, for instance, if I can give you an example here, have a diagram for that, and I'd be so glad to share with you. I hope it is visible. So if it is visible, my top boss, let me know. So that is a different chart. And for me to just ensure that you are able to view it properly, let me shift my camera a little bit. There we go. Yes. So this one is to just show you that in case you have a setup whereby now the meter box is housing the meter as well as the cutout and even everything that is in the meter. The bond is happening at the cutout, where you have the earth connection being bonded to with the neutral. But key point is before the energy meter. All right. So again, at that particular level, you need to understand that our PME is already done at the pole, the immediate pole that is serving the connection. This one will definitely be the PME, protective multiple earthing, that has been connected with the neutral. And then when it gets to this particular point, it is earthed on the ground. So the drop cable still will drop with only two connections or two wires inside. So this is a black, see, this is a black drop cable. The cable has two cables inside, where we have the face and we also have this. So this one, when it comes here, you will still loop it at the neutral connection. So it will again be in contact with this conductor here, the neutral, as well as the PME that is dropping to the ground for earthing purposes. So that if at all there is an issue, the earthing connection at this particular point is weak or has disconnected due to one or two reasons, then excessive charges will go all the way through this cable, through this neutral connection, all the way to the neutral conductor where it is earthed through the PME, so that the excessive charges will travel all the way through the drop cable, get to this neutral conductor at the pole here, the immediate pole that is serving your customer with power, drop through the PME protective multiple earthing to the ground, and then back to the source, which is the transformer. All right. So the bonding will happen at the meter box, and therefore the meter box is also looped. How is our meter box looking? Let me bring our meter box, my top boss. In the meantime, smash the like button. Let me know that you are getting value out of our today's session and you are learning a lot when it comes to the neutral and the earth connection. Thank you so much for being here. I can see a lot of you, my top bosses, already learning. So this is our meter box. I will be talking about some of the important features when it comes to the meter box, and we will be learning a lot. One of them, according to me, being that the meter box should be metallic. A metallic meter box all around is very, very important because of the fires that may start from the meter box. So if at all the meter box is metallic, as you can see at the back, we have a metallic casing here. All right. All around the meter box is metallic. And that is a very important feature when it comes to this important part of electricity. You can see even inside the meter box is completely metallic. There are other meter boxes whereby you'll find that at that particular point where you need to have a connection there, you know, the connection for the cutout, the connection for the double pole miniature circuit breaker, as well as the energy meter. You find that some meters, especially back in the days, this metallic part was not there. There was a wooden part so that it could allow for the screw and then also for the mounting of every other feature that will be in the meter box. But nowadays, that one is not there because of safety reasons. If at all there is arcing that is happening in the meter box, which you can expect as long as it's an electrical installation, and some people may not be able to do regular maintenance work on their property, they will not really consider calling the electricians to do regular maintenance unless there is a problem. So once you have this type of meter box, then the connection is usually safe, because even if there is arcing, any fires or any sparking will only be happening locally in the meter box and will not escalate into burning that property. All right. So that is a very important feature when it comes to the meter box and the safety aspect of it. So the connection here at the double cutout will be like so, or if it is a single cutout whereby you have the neutral, then the earth and the neutral will be looped there. This is before the meter box, I mean the energy meter. And then from there, from the energy meter, we will have the connection of the phase and the neutral all the way to the DP switch, and then from there to the consumer unit. At this time, our earth connection, which has been bonded already, will have to be connected again to the meter box. So you have another bond at the meter box whereby the earth, this earth, as you can see, I've drawn it from this particular point, this red representing the meter box. So the earth connection will be bonded with the neutral, and then from there it will go all the way to the ground, where it will get what we refer to as the earth rod, right? So here we have the earth rod. Now from the meter box, the earth wire will be connected to the earth rod. So this is our earth rod. Is it clear, my top boss? So the meter box has to be bonded with the earth rod, okay, for safety purposes. But again, you might want to ask, why should the earth rod be connected to the meter box? All right. So that is also another question that someone might have. Why should we connect the earth rod, I mean the earth connection to the meter box? Who can answer? Before that, let me just go through your comments, and I'm so glad that you are here commenting and interacting with me. Wow, I have Lance Johnson. What a great name. Afternoon, I'm Lance, watching from Durban, South Africa. Thank you so much, my top boss. Glad to see you here. I have Dennis TB. I'm listening. Thank you so much, Dennis, for your time and sparing this moment to be with me. I appreciate. I have Ivan Kakuru says I'm listening here in Uganda. Thank you so much. I really do appreciate. Dennis says, Dennis Graham, Thika Technical Training Institute. Wow, awesome, awesome, awesome. Thank you so much, my neighbor here in Thika. I would love to really, really visit you, Dennis. Also see what you are doing in your school and especially interact with you when you have your workshop sessions. I hope that we will be able to organize for that, because I'm also looking forward to do campus tours whereby I will be able to interact with the top bosses who also follow me and who are also undertaking electrical installations, so that I can give you an encouragement, at least share my journey, as well as know what you are doing in college, and basically understand your struggles, as well as share my experiences, you know, all the way from when I finished school and even when I was in campus. What was I doing? How was it? How was the experience? And how did I start off in the field? The challenges, the journey generally. I'd be glad to share it. So my top boss, Dennis, I'll be so honored to visit one time. I also have John Calvin. A lot of my namesakes are here. John Calvin, my namesake, says, Happy Sunday to Top Height Electrical. John Calvin from Eldoret Poly, learning a lot from your videos. Wow! There is a time that I was also in Eldoret Polytechnic. Thank you so much, my namesake. Eldoret Polytechnic is a great school, and I know that you are learning a lot from that. I will also like to visit your campus one day if there will be an opportunity to do that, my top boss. Thank you so much. Glad to have you here. Smash that like button if you are learning a lot, my top boss. And thank you. Thank you so much for your interaction here. Thank you so much for, you know, being a part of this. I really do appreciate your time. This cable here, is very, very important. When you see it in an electrical installation, you definitely know this is a representation of safety or earthing. All right. And I was asking, why do you think the meter box is looped to the earthing system? Any electrical installation that is metallic must be earthed. You know, you can't have safety measures. You can't talk about safety. You can't talk about earthing if at all any metallic part is not earthed. So beginning with the meter box, it must be earthed. And so, like I was saying, this meter box, which is metallic, a good meter box should be metallic. Back in the days, we used to have meter box that were wooden. And therefore, if at all there was an issue, let's say there was sparking, that meter box could have been affected by, fire incidences. So at this particular point, another important feature, you see this one is the bottom section of our meter box. So at this particular point where we have the top section, you don't have those provisions like you see at the bottom. Why? So that you can prevent any cases of water leakages into the meter box. You see, the meter box is a part of electrical that is usually installed outside the house. And so if there is a lot of rainfall, if there is a connection whereby the pipes or the conduits are connected here, it can be susceptible to rain, to the leakages of that water. Once it gets into the meter box, then that is a recipe for disaster. The reason why I will have my meter box connected in a manner that all the cables come or exit at the bottom part is so that if at all there is water flowing following the drop cable from the national grid, then the water will definitely find its way to the ground and not enter into the meter box. Also, the path or the cables that exit the meter box all the way to the installation or to the house will also come from the bottom part, so that if at all there is any case of rainfall falling or finding its way on the top of this meter box, will definitely fall to the ground and not interfere with my connection inside. Now, a metallic meter box has to be earthed. Okay, that is very, very important. There is a case where you find that the meter box is connected to a metallic structure. Let's say the electricity installation or the system has been done in a metallic structure. It could be a container, for instance, where we have been having the commercial setup where we have a business that is actually done or undertaken in these containers or metallic structures basically. So we will have this meter box welded on that structure. The best thing that an electrician can do is to ensure that the earthing on this meter box is perfect. When you go to that metallic structure or that setup, it could be a home, it could be a business, and it is made of metals, then the earth connection to the meter box should be very perfect. Also, on that metallic structure, there should be several earthing points, not only one, to ensure that it serves that structure properly. And I will be elaborating much more about that. But the reason why I would prefer several earthing points is because if, for instance, you are talking about 20 feet, 30 feet structure, and you have earthed at the meter box only, and this structure is not made of copper, meaning that the structure is not a good conductor of electricity, you definitely cannot rely on one earthing point. You can even have four or even more, so that the earthing connection will be done in a manner that it is safe for the occupants, or it is very safe for the people that are undertaking a business activity in that particular setup. All right. So glad to have so many of you here. Thank you so much for interacting with my content today. Thank you so much for being here, my top boss. It means a lot to me. Okay, great question from my top boss, John Calvin. John Calvin is from Eldoret Polytechnic. Asks this important question today. Under what occasions can a neutral wire cause shock? This moment, I don't know whether you can get me clearly. Under what condition? Let me bring a DPMCB so that I can be able to elaborate that. I can also come with some cables here, as well as the cutout, so that I can physically show you. Will you allow me? Thank you. Just a second. And I am back. Thank you so much for still being here and waiting upon me. Really, really do appreciate. All right. Under what circumstances or situations can a neutral wire cause a shock? That is a brilliant question from my namesake. Thank you so much for the question. Now, important features to discuss here on that specific question by John is that the neutral has these points of contact which are very important. Number one, at the pole, we have a drop cable connected to the neutral line. If at that point we had an issue where the connection has been disturbed, now at this point we will have this drop cable here. Thank God I have these things to be able to physically show you. If this connection is done in a manner that it is loose, or over time it was loose, then the return path has been compromised. Remember, we said that electricity travels in this manner. It comes in through the face and it goes back through the neutral. Now that path must be very, very perfect. If at all it is compromised, then it means that the path has an issue, and therefore there will be something that we refer to as a floating neutral. Many people refer to it as a return, just one word, a return. This wire or this connection has a return. But in actual sense, what that means is that floating in that path, the neutral is floating, meaning it is not finding its way back to the transformer to complete that loop or to complete that circuit. Now, that return path or that return connection, if at all it is compromised, it will have a shock. All right. meaning it is not finding its way to the transformer. It has nothing to do with the earth connection, all right? Because an earth error is whereby the excessive charges will not find their way to the ground and back to the transformer. So if at all there is a loose connection on the neutral, and which is very, very dangerous as compared to a loose connection on the face, because if at all there is a loose connection on the face, it simply translates to no electricity. So if at all a fuse at the transformer, this is an LV fuse or a low voltage fuse, is burnt or it is open, or there's another term that we normally use, that it has blown because of, let's say, an overload or a short circuit, that in general means that there's no electricity, all right? Because there will be no return path to the electricity if at all the electricity in itself is not present, all right? So at that point, let me give you an example. If, for instance, you were transported or you were carried to a particular location, for you to get a return trip, you must have gone to that location, all right, or to that place. So you cannot be returned if at all you didn't visit that place. So the same way happen. Okay, I know it's a dumb example, but allow me to go with that, John. All right. So for electricity to be, at a certain place serving a certain appliance or a device, it has to go through the face for it to be returned. Now, if the face is interrupted, that's it. There's no electricity, there's no shock, there's nothing. So if at all the return path is compromised, it means that the phase is already present in the system, and therefore the return path has been compromised. That is when someone will receive an electric shock through the neutral. So this is at the that particular point. Again, something very important to note is that this one is a cutout. If this cable, in fact, before we get to the cutout here, if this cable has a loose connection or it has a joint and the joint is compromised, then there will be a problem for the path of that electricity or the current to go back to the transformer. Therefore, it will result to a problem there. If you use your tester, you will discover that there is presence of electricity or current in that or on that tester. Let me try to just grab a tester so that I can be able to, share with you on that. Top boss, if you are finding value out of our lesson, I'll appreciate a like from you. This being our tester here, you place a tester at the neutral. If everything is okay, you will not see anything at this particular point. And if at the drop cable there is an issue, you place a tester on both the neutral and the live. It means that if the tester is on, there is a problem with that particular circuit. This drop cable has been compromised. Now, the drop cable can be compromised if at all there is a joint or a loose connection. A loose connection may come about due to wear and tear, or if at all the person that was doing that connection was actually doing it in a hurry and did not do a perfect one, or probably used the wrong tools, or the connection that was done there, especially nowadays, we see that the connections are not done according to standard, and this is a fault that I place on the national grid people who definitely are responsible for that connection. The recklessness, the carelessness is upon them, and therefore that is very, very wrong. Another issue that may happen is if this pole has been knocked either by a vehicle, or probably there was a forklift or anything that was probably interfering with the stability of the pole, it may compromise that connection there. Another issue is due to the weather. If at all this pole was not correctly erected, and you will find that this pole will start to lean, especially if it is not supported by a stay wire. A stay wire is what is connected to ensure that the pole stays on its position. That is why it is referred to as a stay wire. So that is on that. Now let us go to our double pole. Sorry, before we get to our double pole, we go to our double cutout. So the double cutout, just to elaborate how it looks, this is how it looks like. All right. So a double pole will definitely have this particular point here. This part, you can be able to separate it. This one carries a fuse inside. The fuse is normally 60 or 80 amperes. All right. So the fuse is here. Probably you would want to see how the fuse looks like, my top boss, and I'll definitely show it to you. If you're finding value, smash the like button, top boss. And if you'll be watching this video on a recorded version, I will appreciate your like as well. And if you have not subscribed, subscribe to our channel so that you don't miss these lessons, if at all they mean something to you. So this is the fuse, okay, connecting this part and this part. If at all the fuse is blown, definitely current will not flow from this part to this part, which then means that that particular house will not have supply of electricity. Once you notice that there is no electricity there, you really need to check on this. That is where your troubleshooting skills come in. Studying electrical engineering is one thing, and also being able to troubleshoot some of these cases is another thing. So I just want to show you how the fuse looks like. So this fuse looks like that. It's an 80 ampere fuse. In case there is an issue with the electrical installation, you find that the fuse will be blown. Okay, is it clear enough? There you go. So that is the fuse. So glad to have you here. My destiny says, why do you use two double pole switches at the meter box? All right, that is a great question that most of you have actually asked me, and I will be answering it just right now. All right, now from the cutout, there is also another feature. This feature is for the neutral. Sorry about that. At this point here, we have this part that you will be able to understand it. So you can see that the phase can be interrupted in a manner that you can remove that part which has the fuse, and this part where we have the neutral. You must know this. The connection will be connected at this point here, where we will have the incoming neutral and the outgoing neutral. This part is very important because you cannot disengage. Once you have connected the neutral here, The neutral, the incoming neutral will be connected like this. So using our drop cable at the cutout, this will be the incoming connection for the face, and the neutral will be connected here. So the face can be interrupted, and the neutral should not, once it is connected, it will be continuing all the way from the transformer to the installation circuit. That is a very interesting feature there with the electricity. And therefore the output will be connected at this lower side. Now, to answer your question, my top boss by the name My Destiny, first of all, thank you so much for being here. You said, why do you use two DP switches at the meter box? Yes, for me, I would prefer to use two, but it is not a must. Now, for instance, at this particular point, if let's say supplying the meter box, first of all, the DP switch is very automatic in that if at all there is an issue, there is an overcurrent, the main purpose of the DP switch will be to trip, isn't it? It will trip in case there is a problem. But assuming that this DP switch has failed, or due to one or two reasons, this first DP switch has a problem, and then you have an issue in the consumer unit, and you want to access electricity at this level and switch it off, then you will come and switch it off from here. If this particular DP has a problem, you will then go to the second DP and switch it off. Okay? Again, if at all the energy company comes in and wants to switch off their electricity supplying to the meter, they will definitely switch it off at this particular point. You know, sometimes the company may not necessarily disconnect it at this particular point here. They will disconnect it here. Let's say you only have the DP switch at this point after the energy meter. Then the energy company wants to switch your power off. Either they will disconnect the meter here, or they will disconnect it from here. But if you have the two, then you are at a good you are at a vantage point. Another reason why I'm not talking about any other person, why I would prefer to have the two DP switches is if at all one fails and there is an electrician who has come to do maintenance work, and then they did not have this DP switch, or they cannot access a quality DP switch at that point, but the customer wants electricity at that point, then what I will do is to, you know, get rid of the one that has been damaged or short circuited, so that I can have one. That is like a case whereby you have a spare tire, okay? So that if at all this one fails, you can simply use the second one. So it is a matter of having options. It's not that it is a must for you to have the two. You can only have one and it will work perfectly. I don't know whether my top boss Destiny, that makes sense, but I stand to be corrected. Ivan Kakuru says, I want to join electricity on Monday. Help me. Join how? Let me know. So my Destiny, I don't know whether I've been able to answer you on that. So let me know. Smash the like button, my top boss, if you're finding value. If you give me a like, I will really do appreciate. You know, even in real life, when you like what someone is doing, then you simply either tell them or you say, and then that means that you are finding value out of that, and it will really help me. Also, did you know that you can become a member of our channel By you becoming a member, you are really helping me to continue doing this, because actually uh, it encourages me to continue working. And sometimes for me to buy some of these materials to be able to give these lectures, I have to spend my own money. And even to come up with, like, let's say what I've been showing you, the meter box, this one I have to buy with my own money. So if you are able to support my work by giving me that membership, or buying, you know, buying there are, what do we refer to it, being a member of my channel, or also buying gifts. Do you know that you can buy gifts on this live session? It can really help me to go a long way to be able to buy some more. I'm also looking forward to get into more lessons on three-phase. And what I discovered is that for me to get those materials, I also need to spend. And at the moment, I may not be able to buy most of these materials to execute the work that you are asking me, but I know with time I'll be able. If you are able to get into memberships of my channel, or buy gifts as we get into the live shows, I will really, really appreciate and get resources to be able to further these sessions and these lessons, which I know that you enjoy from what you tell me. Trader Treasury, good to see you here. You say, how can you mentor me personally? All you need to do is to join our course, or our online class that we normally have, and you will learn a lot. I have a course, and I have very many people who have already joined, and they learn a lot when it comes to electrical installation, all the way from what I'm talking about here to the installation itself, troubleshooting. I have covered that. I will also be putting up a link on our description so that you can be able to learn much more when it comes to single phase wiring. When it will come to three phase, you will also learn a lot, and I will also be putting a link on the description. So if you'll be watching this video on record version, you can check on the link on the description, and you'll be able to learn a lot when it comes to electrical. Yes, that is that my top boss. Ivan Kakuru had said that I want to join electricity on Monday. Please help me. Yes, you are very much welcome. Do you have that positive attitude when it comes to electrical? Are you willing to learn? When I was doing my attachment, industrial attachment, I was actually doing it in this company, Electric Kenya Power, which is our grid supply company here in Kenya. And I would go to all of the departments. I was just placed in the Department of Design and Construction, but I said, no, I want to go to all the departments, be it large power, be it maintenance, be it every department, including the survey. I spent some time there understanding how do things work. If someone wants to be supplied with electricity, how do they apply? That is even in the customer service. I went to all those departments and I spent my time there. So if you want to join, develop that interest, and then ensure that you are hardworking in this manner, that you want to know everything and have that interest. And I'm telling you, my top boss, everything will be okay. All right. Thank you so much for that question. And I really do appreciate it. And I wish you all the best in that journey, if that is what you will be able to get into my top boss. So glad to have so many of you here. It means a lot. So that being said, from there, the earthing connection, which is done in that particular setup, be it the domestic, industrial, or any commercial setup, the earthing connection, as we were talking about, is a must for you to have this earth rod immersed into the earth just beneath the meter box or the meter board. The meter board can access or can house more than, let's say, how many energy meters? Four. That is a meter board, four and above. And if it's a meter box, then we are talking about probably three, two, or even one. But from four all the way to several meters, that is a meter board. And you are supposed to ensure that the earth rod is there. Another thing to take a note is that the the material to be used when having this earth rod matters a lot. You cannot just have an earth rod in the earth and assume that everything is okay, because the excessive charges that will flow from the meter box or the meter board to this earth rod must find their way to the ground also. If at all the ground is not conducive for the charges to find their way in and back to the transformer, it means that there will be a very huge resistance. And those charges may still stick to the earth rod, to the earth connection, and even to the installation. So you must ensure that that path to the ground is smooth and without or very minimal resistance. Aha, Steve In. Wow, what a great name. Steve In. I've also seen you interact with my content, and I'm super, super grateful to have you also join our live session. So thank you so much, Steve In. You said that you have just joined. Thank you so much. You are very much welcome. Ivan says, no, 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 that one I had already read it. So thank you so much for joining, Steve In. So that connection to the earth rod is very important. I talked about the earth where you're supposed to do the earthing, or where you're supposed to do the earth rod. That video is already out. I will also be putting a link on the description. You can watch it and learn much more about the ground where you are supposed to have that earth rod. It is very important, plays a very key role in an electrical installation, because if the earth is poor, if the earth is bad for you to have that electrical earthing, then it means that the entire electrical is compromised. All right. So I hope you have understood up to this particular point, including bonding the neutral and the earth connection. That is before the energy meter. That is very good. But again, an issue will arise if at all you try to bond the neutral and the earth at the consumer unit or after the energy meter. Some energy meter will sense that as a fault, and that is why you will find that there is a fault that is now referred to as a bypass. This one is indicated by the CIU, the customer interface unit, that is feeding the energy meter with tokens. That one that is normally in the house. So if at all you find that there is a bypass, it means that this energy meter will not actually be giving the correct readings, meaning that it will be consuming a lot of tokens or units. Therefore, you are supposed to do what we refer to as a separation between the neutral and the earth connection, because this energy meter will even get to a point whereby after the tokens get to zero or they are consumed, it will start recording a negative, so that if at all there is -2, -3 units, you will have to pay for those units, and they usually get consumed very fast, so that you pay until it indicates a zero, and then from there you can buy units. That one is usually very detrimental to the user, because you are charged extra. So top boss, I hope you have understood that. That is normally for some energy meters. Not every energy meter will have that issue, but if at all you are doing an electrical installation, therefore you must ensure that that connection is not there. Previously, that was done, but there is no point of you looping the earth and the neutral, especially after the energy meter, to avoid those errors and to avoid the customer paying all of those charges. Top boss, where are you streaming from? Before we end this live session, I would like to know if you have any questions so that you can be able to tackle and so that we can also be able to talk much more when it comes to safety of electrical. This is in reference to earthing. Smash the like button if you have found value in our today's session. Thank you so much for the comments that are coming in. And if you'll be watching this video in a recorded version, then feel free to interact with me through the comment section. Let me know what you think about our today's video, and I will really do appreciate. Now, as I conclude, let me just touch on something else that had been asked by my top boss regarding a neutral connection that may actually affect someone to electric shock. And this is in regard to the double pole. If at all you have the double pole at this point and there is a loose connection, that one is a very common problem where you will find that people will do these electrical connections and they will not do a perfect connection on the neutral, because we are so much fixated on doing connections that are very tight on the face or the live connection, but we fail to do a perfect connection on the earthing, and therefore exposing our customers to a lot of electrical problems, and therefore you will have a loose connection on the neutral or the return path, which leads to a floating neutral that actually carries a lot of charges that can electrocute a person and also can injure uh, animals that they stay with, or even cause damage to electrical appliances. So when connecting all the electrical connections, you must ensure that the connection is done very perfectly. When it comes to this setup whereby you have an energy meter at the pole, it is important for you to ensure that the earth connection is kind of independent at the domestic setup or at the industrial setup, whereby you come up with the earth rod or the earth pit. You know, when you are setting up the earth rod, you have an earth pit where the earth rod will be immersed. And then you localize that connection in the sense that even without bonding the earth to the neutral, you ensure that that earthing system is very safe, so that in case there is excessive charges in the electrical system in the house or in that setup, in case there is any leakages on the consumer's appliances, all of those charges will be directed to the ground, courtesy of the perfect earthing system that has been created in that specific home or in that industrial setup. If you are talking about a three-phase, or if you are talking about sorry about that delay. If you're talking about an industrial setup, or if you are talking about this particular point here, it is very important for you to also take note that this three-phase connection, we have the phase, the first one, conductor, which is a red phase, a yellow phase, and a blue phase. This is a return for our case here, which is also looped to the ground through this protective multiple earthing. So you'll have these three phase drop cable to serve all of these uh, uh, the whole of this apartment. Okay, so the earth connection should also be carried with a lot of weight, my top boss. All right, so that is how you ensure that you do that perfect connection over there. And you must ensure that the ground or the earthing at this particular point on the ground is perfectly carried out, as well as the PME. All right. So from there, every electrical installation at the consumer unit, our consumer unit, just to elaborate something, on the consumer unit, we have, so this is a very good consumer unit here that I have. It is a 12-way consumer unit. I don't know whether you can be able to see it clearly. It's a 12-way consumer unit. You can have very many connections there, MCBs. So let me just get into the consumer unit and show you also another feature of the earthing connection. And the earth connection is never interrupted the same way the neutral connection is never interrupted when you connect a neutral through the MCB, or that is the double pole MCB, which serves as the main switch to the customer, or at the meter box where you have that connection. You must ensure that that connection is never interrupted. So at this particular point, you will have that bar, which is the earth bar. It is also in contact with the metallic surface of this consumer unit. Remember, we said that any metallic part in the electrical system must be earth. So the earthing connection is done at this point and also at this point. So my consumer unit has two earthing points, as you can see, to guarantee the user maximum protection when it comes to earthing. All right. So that has been my time, my top boss. Thank you so much for finding time out of your schedule to watch this live stream. My name is John, and it was glad carrying you out in this or taking you through this particular important aspect that we refer to as earthing. Thank you so much for tuning in. Thank you so much for watching. If you'll be watching as a recorded version, I will appreciate your like. And if you have not subscribed to our channel, subscribe to our channel so that you don't miss the future videos or lessons that will come up. If you have anything that you'd want me to address or talk about in electrical, feel free to leave a comment talking about that, and I will be glad to do it, my top boss. Thank you so much for your time. Until next time, see you then.